Hello and welcome to Igniter. My name is Ankon. Today we will discuss about the displacement time graph of linear motion, which is very important for class 9 ICSE physics. So a lot to know, a lot to discuss. Before that, please hit the bell button to get a quick update of all the videos. So let's go. Starting point. So take an example that you are throwing a ball upward. So this is the initial position of the ball, and after 2 seconds the ball travels. After 2 seconds the ball travels 20 meter upward movement. So this is the 20 meter. So this is the final position after 2 seconds of that ball. So now I draw the relevant diagram, actually displacement time graph of this particular event. So this is displacement, and this is the marking of displacement. This is origin, 0 second, 1 second, 2 second, and this is 10 meter, 20 meter. So this is the origin, and this is the 2 second and 20 second, and now I draw the graph. Look one thing here, the in x2 and y2 is always greater than x1 and y1, so the slope is always positive slope. Now if the slope is negative, it actually indicates the body is returning to the starting point. Now take the example that the body is coming down. So this is when the time is 0 second. The height of the ball from the ground is 20 meters. So this is the displacement when the time is 0 second. This is the 20 meter height, and after 1 second it's just coming down 10 meters. So height of the ball is now 10 meter, and after 2 seconds it actually comes down, and so the displacement is 0 meter. So now I draw the relevant diagram of this event, and this is the time axis. So this is 1 second and this is 2 second. So this is the time axis, and this is the displacement axis. So look, when the time is 0, one thing before that, this is 10 meter and this is 20 meter of the displacement. Now look, when the time is 0, the displacement is 20. So this is the 20 meter point, and when the time is 1 second, the height is 10 meter, and when the time is 2 second, the displacement is 0. Now I join every point. So this is actually the straight line of these events, and this actually indicates the negative slope. So this is the picture of the negative slope. Look one thing, the final position here, the displacement is negative but the time is positive, so the slope is negative here. Now case 1. So the case 1 is when the body is stationary. Body is stationary actually means the displacement is same. So displacement is same at any instant of time. So this actually means the displacement is not changing with the changing of time. So I take a point of displacement between 20 and 30, and this is not changing with the changing of time. So this is the graph of a stationary object. Look, when the time is 1 second, the displacement is same. Time is 2 seconds, displacement is same. The time is 3 seconds, displacement is same. time is 4 seconds, displacement is same, and time 5 seconds, displacement is same. So this is the actual graph which is parallel to the time axis. So when you saw a when you will see a graph which is parallel to time axis, this actually means the body is stationary. Now case 2. So case 2 is if a body is moving with uniform velocity. It means the displacement increases by same amount in each second. So take an example. This is time and this is displacement. When the time is 0, displacement 0. Time is 1, displacement 10. Time is 2, displacement 20. Time is 3, displacement 30. Time is 4, displacement is 40. And now I will draw all these points on that graph. So when the time is 0, displacement is 0. This is 0, 0 point. And when the time is 1, displacement is 10. This is the point. And when the time is 2, displacement is 20 meter. So this is the 220. When the time is 3 second, displacement is 30. This is the 330 point. This is the 330 point. When the time is 4 second, when the time is 4 second, displacement is 40. This is the 440 second. And now I will join all these points, and this is the final graph of these points. And now I will calculate the slope from this following displacement and time graph. So here the slope is equals to, before that I have to take 2 points to calculate the slope. Take this is point A and this is point B. So the coordinate of point A is 2 and 20, and the coordinate of point B is 3 and 30. So the formula of the slope is m equals to del y by del x. This is del y and this is del x. So here del y is, this is the y2, and this is 30 is the y2, and here y1 is 20. So this is the del y and this is the del x. Del x is 3 minus 2. 3 minus 2. Now 30 minus 20 is 10. 3 minus 2 is 1. So final answer is 10. So before I told you that the slope of the displacement time graph actually indicates the velocity. So here this is the numerical value of the velocity. So in this way you can calculate the velocity from a displacement time graph. Here the velocity is 10 meter per second. Look, one thing, always write the unit. Here the unit of velocity is meter per second. Now I will show you another example of time and displacement graph. This is different from previous. Here I will take 7 coordinates. So when the time is 0, displacement is 0. Time is 2 second, displacement is 20. Time is 4, displacement 40. Time is 6 second, displacement is 60 meter. Time is 8, displacement 40. Time is 10 second, displacement 20, and time is 12 second, displacement is 0. So now I will draw each points each point on this graph, time is 0, displacement is 0. So this is the 0 point, and when the time is 2 seconds, displacement is 20. When the time is 2 seconds, displacement is 20. This is the 220 point. When the time is 4 seconds, displacement is 40. This is the 4 and 40 point. And when the time is 6 seconds, displacement is 60. This is the 660 point. And now when from 6 to 8 seconds, look one thing, here the displacement is decreasing. So from 60 it comes down to 40. So this is the 840. When the time is 10 seconds, so displacement is 20. So here it is 10 seconds and displacement is 20. This is the 1020 point, and when the time is 12 seconds, displacement is 0. So this is 0, and now I will join all these points. So this is the total graph of following points, and now this is positive slope and this is negative slope, because displacement is decreasing here with the increasing of time. So from here I will take 2 points. So this is a 1 point and this is the other point. So I will take 3 points here. This is A and this is B point. So from these 2 points I will calculate the slope. Slope equals to slope of the AB is del y by del x. So here del y is, look here the displacement is 60. So and the coordinate of this point is 660, and here it is 0. The coordinate of A is 0. So here del y is 60 minus 0. So this is 60 minus 0, and del x is 6 minus 0. So this is 6 minus 0. So 60 minus 0 is 60 and 6 minus 0 is 6. So now the answer is 10. So the slope of the AB is 10. So the velocity from this side is 10 meter per second. So the velocity from AB curve is 10 meter per second. Now I will calculate. Now I will calculate the BC side, which is another side. Look, this is the BC side. So here the initial point is B point and final point is C point, and the slope of BC is same formula, del y by del x. So here the coordinate of C point is 12, 0, because displacement here is 0. So the change of the displacement or change of y-axis is final minus initial. The final is 0 and initial is 60, and the del x, that is the difference of time here, is 12 minus 6, because 12 is the final time and 6 is the initial time. So minus 60 by 6 here, and the answer is minus 10. So here the velocity is minus 10 meter per second. So in this way we can calculate the total, as this is the velocity of this side and this is the velocity of this side. I hope you will understand this. So now this is the proper example of previous graph. This is when the ball is throwing upward. So when the time is 0 second, that is t is 0 second, ball is on the ground, displacement is 0, so that's why displacement is 0. And when the time is 2 second, the displacement is here, when the time is 2 second, displacement is 20 meter. So when the time is 4 second, the displacement is 40 meter, and when the time is 6 second, the displacement is 60 meter. So this is the maximum height the ball reaches before it comes down, and now the ball is coming down, and this is the actually part of negative slope. So now when the time is 8 second, you can see that d is 40 meter, that is the displacement is 40 meter, because the height from the ground it is 40 meter. And after 10 second, the height of the ball, after 10 second, the height of the ball is 20 meter. So this is displacement is 20 meter, this is 20 meter, this is the height. And after 12 second, it comes down to the ground, so the displacement become 0. So this is the diagram, or this is the example of previous diagram. Now case 3. Case 3 is if a body moves with a variable velocity, not uniform velocity. This is variable velocity. The variable velocity actually means the displacement time graph is not linear. So before you saw every displacement time graph is linear. So now this is not linear. Take an example, when the time is 0, displacement is 0. So this is the point of 0, 0. When the time is 2 second, displacement is 10 meter. So when the time is 2 second, displacement is 10 meter. So this is the point of 2 and 10 meter. When the time is 5 second, displacement is 30. So when the 5 second, this is 5 second, and this is 30 meter. So this is the point of 530. So when the time is 6 second, and displacement is 47. So this is the 647. This is the point. Now if I join all the points, look, this line is not linear. So as always, please like and share our videos. If you have any query, you can write on our comment box below, and subscribe our channel to get all the latest updated videos. Thank you for watching.